All right, welcome to lesson 30. In this lesson, we're going to learn about solving equations by factoring. I'll take a moment now to remind you that the unit that we're currently in goes from lesson 25 through lesson 31. So after today's lesson, there's one more in this current unit, and then we'll have our second test. Lesson 31 is a little different though, so this lesson, it really is kind of the last factoring lesson. We've been doing a lot of factoring. At this point, you know a lot of different methods of factoring. In the previous lesson, lesson 29, you got even more practice, just kind of keeping all those different methods straight and hopefully getting some review in that lesson as well and telling the problems apart. In this lesson, we're not just factoring, we're using factoring as a way to help us solve equations. Okay, so let's talk about that. To solve an equation by factoring, use the zero product property. Sometimes this is called the zero factor property as well, depending on the book and the teacher. So here's the property or the rule. It says if AB equals 0, then A equals 0 or B equals 0. Okay, so what this means, AB, remember that means A times B. What this means is if you have a product, if you have two numbers being multiplied together and they're equaling 0, the product of those two numbers is 0, the only way that could happen is if one of the factors actually was 0. Think about it. If you think of two numbers that multiply to 0, it has to be 0 times a number or a number times 0. 0 has to be 1 or even both of those factors. So we're going to use this property to solve equations by factoring. Now you've solved equations before, not really in this class, but in the previous class, Intermediate Algebra Part 1, you would have learned how to solve what are called linear equations. And generally those equations had one solution. What you'll see with the equations we are going to be dealing with in this lesson, most of our equations actually have two solutions and sometimes even more than that. And another difference is our variables will have exponents on them. Okay, so let's take a look at our steps. So again, the zero product property says if A times B equals 0, then A equals 0 or B equals 0. And here are our steps for solving equations by factoring. Step 1, write the equation in standard form. Okay, standard form, you'll see that phrase a lot in math. I was going to say in algebra, but really all of math. Here's what we mean right now. Standard form, another way to think about it is descending order with all of your terms on one side of the equal sign and then 0 on the other side. So standard form looks like this. Ax squared plus bx plus c equals 0. There may or may not be 3 terms in your problem. There may not be a term that has an x or an x squared. Sometimes there'll be an x to the third. So there's a lot of variety, but in general, have your terms in order from highest exponent to lowest and get them all on one side and then 0 on the other side. Okay, so that's step 1. Step 2, that's the big one, factor. So take all the knowledge that you've acquired over these past many lessons that we've been working on and factor. It could be any kind of factoring, greatest common factor, grouping, difference of squares, trinomials, all the different kinds are possibilities. So that's still where most of our work is going to be put in the actual factoring. But then there's more. After we factor, then we set each factor equal to 0 and solve, meaning and solve those equations. So that's the A equals 0 or B equals 0 part of this. Okay, so if you have two factors, A times B equals 0, then either A is 0 or B is 0 or both. Okay, so you're going to essentially split your factors up, set them each equal to 0. It's usually 2 equations. Sometimes there's more, depending on the problem. You'll solve those. Now, those equations will be more familiar looking. They'll be what are called linear equations. For example, it might be like x plus 2 equals 0, or 3x minus 1 equals 0. And we'll review how to solve those. And finally, step 4, check each solution. Usually there's 2, maybe more. Check each solution in the original equation. And remember to check what that means for equations is you take your solution, such as x equals 2 or x equals 5 or something, and you plug it into the original. So you replace x with the original number in your original equation, you simplify, and then you make sure that your equation is true, that both sides are equal. So that's sort of a preview of what we're going to be working on. So let's take a look at our first problem. So example number 1 looks like this. X squared plus 15 equals 8x. Okay, so a couple of things right away. You might be, at this moment, remembering some things you learned about solving equations before. So you might remember something like, okay, do I have to get x on one side, get x by itself? That's not really applying right now because there's x squared over here on the left side, but then there's 8x on the right side. And if I put the x's together, you're not going to be able to combine those. Those are not like terms. So the former ways that you might be remembering for solving equations, they're not really going to work here. We are going to solve using factoring. So let's remind ourselves of our steps that we just saw. Step 1, write the equation in standard form. Ax squared plus bx plus c equals 0. In other words, get 0 on one side. So we don't have that right now. We have x squared plus 15 equals 8x. Leave the x squared where it is. So let's get all our variables on the left and all our terms on the left. So what we really need to get rid of or move is this 8x. So what I'm going to do is subtract 8x on both sides of the equation. So I'm writing minus 8x on both sides. 8x minus 8x is 0. So we have 0 on the right side. Now what we have on the left side, we had that x squared plus 15, then we just subtracted 8x. None of those are like terms. So let's make sure our terms are in descending order, meaning highest exponent to lowest. So we'll start with x squared. And then next would be minus 8x. That's what we just subtracted. And then we still have the plus 15. So x squared minus 8x plus 15 equals 0. Now it looks kind of like what we see in step 1. Now it looks like the equation is in standard form. So we're good there. We did that. Now let's move on to step 2, factor. So what kind of factoring are we dealing with? Let's take a look. We have x squared minus 8x plus 15. This is a trinomial, 3 terms. It's starting with x squared. So this is one of the earlier kinds of trinomials that we saw in this class. The first term just has that leading coefficient of 1. There's no number that you can see in front of the x squared other than there's an invisible 1 there. So if you have x squared, that means you can set up your 2 parentheses, your 2 kind of binomial factors, and put x in the beginning of each parenthesis. So I have x times x, because x times x will give me x squared. I've left a space for the other 2 numbers. Those last 2 numbers need to multiply to 15 while also adding up to negative 8. So my factors of 15, of course, 1 and 15, 3 and 5, and then don't forget about negatives, negative 1 and negative 15, and negative 3 and negative 5. The combination that has a sum of negative 8 is that last choice, the negative 3 and negative 5. So that's what I'm going to fill in my parentheses. So here's the fully factored part of this. So it's going to be in parentheses x minus 3, close parentheses, and then my next parentheses, x minus 5. And that's equal to 0. So I have x minus 3 times x minus 5 equals 0. So that was step 2. We factored. So here's what we did so far. We subtracted that 8x to get it out of the way and get 0 on one side. Then what we just did is factor. And now what we're going to do is set each factor equal to 0 and solve. Okay, because I'm a little short on space on my slide here, I'm going to take us to a blank whiteboard page, and we'll continue there. But what I'm going to be doing is setting each factor equal to 0. What I'll be writing is x minus 3 equals 0 and x minus 5 equals 0. So that's what's coming next. All right, so x minus 3 equals 0. I'm saying and, whoops, sorry. Trying to talk and write at the same time. It's tricky. So here's what I wrote so far. X minus 3 equals 0. And I'm also going to write x minus 5 equals 0. Now, obviously, both of those things can't both be true at the same time, but that's not exactly what we're saying. We're saying there's two different possible answers that could make this equation true. And that might be something a little new for a lot of us. Okay, so the two equations I have are x minus 3 equals 0 and x minus 5 equals 0. So now let's solve them separately. They each get their own set of steps and their own final answer. So for x minus 3 equals 0, here is where I can finally get x by itself on one side. I'm adding 3 to both sides. 0 plus 3 is 3. So one of my solutions is x equals 3. With the other equation, x minus 5 equals 0, I'm going to add 5 to both sides. So I'm writing plus 5 plus 5. The minus 5 plus 5 cancels out. X equals, and then 0 plus 5 is 5. Okay, so this is it. So these are our two solutions, x equals 3 and x equals 5. Now I'm going to keep going here because we do have a fourth step which says to check each solution. I also want to let you know that when you get two solutions like this, what we often do is write them in what's called a solution set. So see, I've started these little squiggly brackets here, and now I'm going to list each of my solutions. I'm going to write 3, comma, 5, and then close my brackets here. Okay, sorry, I had to pause there for a second. So we just wrote some brackets and then 3, comma, 5 in the brackets and then closed up the brackets. Now this is a list of solutions. The order does not actually matter, and I'm glancing at my answer key I had made ahead of time, and I had them in the opposite order. Both are fine. So again, this is called a solution set. It's essentially a list of solutions. You may have seen this before when solving equations, but it was kind of unnecessary when we had equations that had just one solution. So, all right, let's finish up and do our very last step. So step 4 is checking our solutions, and we do need to check each one. Okay, so I'm going to go back and write out the original problem, which was x squared plus 15 equals 8x. So going back to the original problem, the first thing I'll check is 3. So I'm going to replace 3 with, I'll replace x with 3. So instead of x squared, I'll write 3 squared plus 15 equals, and then over here, 8x is going to be 8 times 3. Okay, and then we'll just simplify and make sure that both sides of the equation are equal. So 3 squared plus 15 is what we have on the left side. 3 squared is 9, and then 9 plus 15 is 24. Meanwhile, on the right side, 8 times 3 is 24. So it checks. 24 equals 24. This is a way to check if a number is a solution to an equation. So 3 makes the equation true. It checks out. Now we had another solution, so we will also check x equals 5 and see if that one also is a solution. So I'm pretty much doing the same process again, writing out my original equation, x squared plus 15 equals 8x. This time I'm going to replace x with 5. So now I'm going to write 5 squared plus 15 equals 8 times 5. So again, replacing the x with 5. So 5 squared plus 15 equals 8 times 5. 5 squared is 25, plus 15 is 40. Meanwhile, on the right side, 8 times 5 is 40, and 40 equals 40. So remember, as you're checking solutions, if it's been a little while since you've done this, when you're done plugging in your solution, what you should see is that both sides of your equations or both sides of your equation are equal to each other. So the fact that I had gotten 24 equals 24 or 40 equals 40, the number 24 isn't really significant here. It's just the thing that's significant is that I'm getting 24 on both sides. Whatever you get on the left, you better get on the right as well. If not, that means we might have made an error. Maybe we had missed a sign somewhere, and we should go back and check our work. All right, so that's the end of our first example. So let's see, we wrote our equation in standard form, we factored, and then we set each factor equal to 0. And then what we just did to finish up is we checked each solution. And we wrote our answers in a solution set, which was essentially some brackets, and the numbers were in the brackets with a comma in between. All right, that was example 1. Let's move on to example 2. So our next problem, 14a squared equals 2a. So we'll try to run through the same set of steps here. Step 1, write the equation in standard form. In other words, we need 0 on one side. And generally, I'll recommend that we get 0 on the right side. Either side is fine. Or maybe notice wherever the squared term is, just leave that one where it is and then move everything else with it. So I'm going to leave the 14a squared where it is, and let's just move the 2a over to the other side. So I'm subtracting 2a on both sides. Now, in case anybody's wondering, if you're looking at this 14a squared minus 2a, this is not 12, this is not 12a. Those are not like terms, so do not combine them. We're just going to write 14a squared minus 2a. Keep those terms separate, and then equals 0. That was our first step, step 1. We got the equation equal to 0. Now step 2, we're going to factor. Okay, so you'll notice this is not a trinomial like last time. There's not 3 terms here, there's only 2 terms. Okay, sometimes when we had 2 terms, recently we've been seeing perfect squares and perfect cubes, and there's formulas. That's not really happening here either. 14 is not a perfect square or a perfect cube. So the type of factoring that we can do here, go all the way back to the beginning of what did we first learn when we learned about factoring. We learned about GCF, taking out a GCF, or greatest common factor. And that's what we can do here. 14a squared minus 2a. The greatest common factor between 14 and 2 is going to be 2. And the greatest common factor between the variables is the one with the smaller exponent, which in this case is a. So I can factor out 2a. So I'm writing 2a, then I'm opening up some parentheses. If I divide each of those terms by 2a, here's what I would have left in the parentheses. 14 divided by 2 is 7. A squared divided by a is just a, and then minus. 2a divided by 2a is actually 1. So what I've written in parentheses is 7a minus 1. So here's what we have so far. 2a parentheses 7a minus 1 equals 0. So we factored out a GCF of 2a. All right, we're on to step 3. After we factor, next is when we set each factor equal to 0. Okay, each factor, what does that mean? Well, last time it was 2 different parentheses. Factors don't necessarily have to be in parentheses. It's just a term that's being multiplied by something else. So in this case, that GCF that we took out, that's a factor. Okay, so what we can do here is take that first factor, 2a, and set that equal to 0. So 2a equals 0. And then my second equation is 7a minus 1 equals 0. Okay, so we're setting each factor equal to 0. Okay. Okay, just checking my notes here. I think we're good so far. So we had 2a parentheses 7a minus 1. 2a is a factor that we set equal to 0, and then 7a minus 1 is another factor equal to 0. Now we solve for a. There's 2 equations, so we will expect to get 2 answers. All right, so let's go with the first equation, 2a equals 0. If we solve for a here, let's divide both sides by 2. 2a divided by 2, that cancels out to just 1a or just a. 0 divided by 2 is 0. 0 is an answer a lot of the time. Sometimes students get confused here and think, well, that can't be true. 0 can't be an answer. Yes, it can. 0 is a number, and you will see problems like this where you do have 0 as one of your solutions. So a equals 0. Moving on to the next factor, 7a minus 1 equals 0. Let's add 1 to both sides. So I'm writing plus 1 to cancel out with the minus 1. Then I have 7a equals 0 plus 1 is 1. Divide both sides by 7. We don't need decimal answers here, okay? So just leave it as a fraction. I have 1 divided by 7. That's just 1/7. Okay, so it looks like we have our two solutions. A equals 0 and a equals 1/7. So I'm going to write my solution set. So I'll write some squiggly brackets here, and then I'll write 0, comma, 1/7. Close the brackets. Now, step 4 we haven't done yet. Let's go over and check our answers, kind of like how we did before for our previous problem. And I'll take us to the whiteboard to do that. Okay, so remember the answers that we got were 0 and 1/7. Our original problem, go all the way back to the beginning, it was 14a squared equals 2a. So let's start by checking a equals 0. Okay, so I will replace a with 0. So 14 times 0 squared equals 2 times 0. I've replaced a with 0. 0 squared is 0, and 14 times 0 is 0. On the right side, 2 times 0 is 0. So we're getting 0 equals 0. That is a true statement. So yes, that works. Let's try the same thing with 1/7. So once again, I'll write out the original equation, 14a squared equals 2a. 14 parentheses 1/7 squared. And just to be clear, 14 and then parentheses 1/7. I close the parentheses and then I put the exponent on the outside of parentheses. So we're going to need to square the 1/7 coming up here. On the right side, 2a, I can write 2 parentheses 1/7, or 2 times 1/7. Okay, let's talk about the parentheses and the exponent over here. So when you square the 1/7, that's 1/7 times 1/7, which is 1 over 49. 1 squared is 1 for the numerator, and then 7 squared is 49 for the denominator. Okay, so writing this out, it's now 14. I'll put that over 1. That seems like that'll be helpful. So 14 over 1 times 1 over 49 equals, let's do 2 over 1 times 1 over 7. Okay, the 2 over 1 times 1 over 7, that's not going to reduce at all. Let's just multiply across there. So on the right side, we're just getting 2/7. I chose to do that one first because it looked a little easier. Let's go back to the left side. 14 over 1 times 1 over 49. If we multiply across, what we would get is 14 over 49. Those two numbers have a common factor. And actually, let's just notice that right now before we multiply across. 14 is 2 times 7, and then 49 is 7 times 7. So let's reduce them right now by dividing by 7. This is called cross-canceling. So 14 divided by 7 is 2. 49 divided by 7 is 7. Okay, so now what I have is 2 times 1 is 2 for the numerator, and 1 times 7 is 7 for the denominator. So our check ended up looking like this. At the end, we have 2/7 equals 2/7. True, and it checks. Okay, so obviously a little bit more effort required to check when there's a fraction involved, but if you did your steps correctly before, you should expect things to work out nicely at the end here. Okay, so that's what it looks like to check. And again, like we did earlier, you can write your solution set as 0, 1/7. You could also write the 1/7 first. That does not matter. All right, good. So 2 down, 2 to go for our notes here. That was example 2. Now let's look at example 3. Okay. I'd like to tell you something right now. So a little tip that you're going to probably learn in college algebra. I find it so helpful that I'm going to tell you now. The degree of your equation will tell you the number of solutions you should expect. What is degree? Okay, we learned about that in our previous unit. I think it was like lesson 21 or something. Remember how we found degrees of polynomials? Generally, it was look at the highest exponent. Okay, so in this problem right here, let me just read the original problem. X to the fourth minus 65x squared plus 64 equals 0. Okay, so this is already in standard form from highest exponent to lowest. It's already equal to 0. This term with the highest exponent right here, that x to the fourth, that's going to give us a clue about how many solutions we're going to expect. So our degree is 4, and I'm telling you that that is a clue about the number of solutions. So I'm going to write a note that we're going to expect 4 solutions. So generally speaking, the number of solutions matches the degree. Now there's some little exceptions to that, so I need to be careful. Sometimes the solutions are imaginary rather than real, and that's not something we cover in this class. Sometimes the solutions repeat. So for example, if you factor something and get x minus 3, x minus 3, it kind of feels like there's 2 solutions of 3, but really it's really just 1. Anyway, so there's exceptions to this, but I'm going to say in general, overall, the degree of your equation is the number of solutions. That's my long way of saying we're going to get 4 solutions, everybody. All right, so let's see if we can factor this. There is no GCF in this problem. All right, and once again, the full equation is x to the fourth minus 65x squared plus 64 equals 0. For our last 2 problems, we had to get the equation equal to 0, and that's already done for us here. So we're just going to start factoring. We're counting the number of terms. We have 3 terms. This is a trinomial, so I can set this up using 2 binomials. So I'm setting up 2 parentheses here, 2 sets of parentheses. Okay, let's look at the first term, x to the fourth. If I'm thinking about FOIL, I need my first 2 terms to multiply to this first term in the trinomial. I need my first 2 terms to multiply to x to the fourth, in other words. So instead of starting with x times x, I'm going to start with x squared times x squared. That's going to be my 2 first terms in my parentheses. So x squared times x squared, that works because that multiplies to x to the fourth. And the reason why it works is 2 plus 2 is 4. You can add the exponents. Okay, now let's move to the last term, which is 64. So when I saw this number, I thought, oh, 8 times 8. So I'll just let everybody know this is going to be wrong, but I want to show you why it's wrong first. Okay, so we're about to do a wrong answer. I'm going to write 8 and 8. Okay, 8 times 8 is 64, but no matter how you play around with the signs here, we're never going to be able to do that full distributing or FOIL process and get this middle term of minus 65 x squared. So here, let's try it, right? So if I need my last 2 terms to multiply to 64 positive, either it's positive 8 and positive 8 or negative 8 and negative 8. Either way, when we FOIL, here, I'll try one combination, x squared minus 8, x squared minus 8. That would be x squared, or sorry, x to the fourth, my mistake, minus 8x squared minus 8x squared, and then plus 64. Those middle terms are not adding up to that minus 65x squared. Okay, so sorry, it's not going to be any combination of 8 and 8. So what's it going to be? All right. What it's going to be is possibly the last thing you might try. It's going to be 64 and 1. Okay, and they both have to be negative. So my last 2 terms have to multiply to 64, and when I FOIL, they have to add up to negative 65. Okay, so factors of 64 that add up to negative 65, it's going to be minus 64 and minus 1. Okay, so I'm starting off my factoring like this. Well, I guess I already started it and got a wrong answer, but now my next try is going to be this. X squared minus 64 times x squared minus 1. And if I check that by distributing, I would get x to the 4th minus 1x squared minus 64x squared, and then plus 64. See that? Those middle terms add up to that minus 65x squared. So that's why it works. Okay, we just worked kind of hard to factor that, and we're not done. That was step 2. Okay, so step 1 was already done for us. This equation was already equal to 0. Step 2, factoring. This is a harder trinomial to deal with because it started with x to the 4th. Here's where we are. We have x squared minus 64, x squared minus 1. We can continue this. Okay, this can be factored more. So take a second look at each of those parentheses. X squared minus 64, that is a difference of squares. So let's break that up more. This is now factoring completely. Okay, so we factored, but we can keep factoring. We can go more. X squared minus 64 can be broken up into x plus 8, x minus 8. That's called the difference of squares. You learned that when we went over special factoring. Same thing with the x squared minus 1. That is also a difference of squares. That's now x plus 1, x minus 1. Okay, equals 0. So take a look. We have 4 factors now. Each of them is in parentheses. Here's what we have. X plus 8, x minus 8. X plus 1, x minus 1 equals 0. So now we get to our third step where we set each factor equal to 0. So because we have 4 factors, we will end up with 4 little equations. X plus 8 equals 0. X minus 8 equals 0. X plus 1 equals 0. And then x minus 1 equals 0. If we solve each of those equations for x, we can do it either by adding or subtracting, depending on the equation. We will get negative 8, positive 8, negative 1, positive 1. Those are our 4 solutions. Okay, so our solution set, and once again, running out of space, taking us over to the whiteboard. Here's the solution set, and then we'll do the check as well. So our solution set, oops. Here's what it looks like. Oh, and I'm getting a little sloppy with my squiggly brackets. So that's okay. Negative 8, positive 8, negative 1, positive 1. Okay, now technically we should check each one. For the sake of time, I will just check one of these solutions just to give you the idea of what it would look like. Let's just check our first one. But just know that you could check all 4, and all 4 should result in a true equation. So we'll just check negative 8, just so you can see one of these. All right, now our original equation, remember, was x to the 4th minus 65x squared plus 64 equals 0. Okay, so I'm replacing x with negative 8. Oh boy, okay, so my first term is negative 8 in parentheses to the 4th. Okay, and next we have minus 65, and then in parentheses, instead of x squared, now we have negative 8 squared, and then plus 64 equals 0. Okay, everybody, let's use our calculators to help us along here. So negative 8 to the 4th, remember that means you're doing negative times negative times negative times negative. You're writing out that negative 8 4 times. Negative 8, negative 8, negative 8, negative 8. If you use your calculator for the exponent, just make sure you keep the negative 8 in parentheses. If you don't, you're going to end up with a negative answer. And I hope you can see, if you write out 4 negatives, you can kind of pair those together. Negative times negative is positive, negative times negative is positive. This is going to turn into, our first term, positive 4,096. Okay, next. I still have that minus 65 times. The next thing we have is this negative 8 in parentheses squared. Well, that's really like negative 8 times negative 8, which is positive 64. And then finally, I have plus 64 equals 0. Okay, so just to recap where we are, we're checking one of our solutions. We're checking negative 8. I've replaced x with negative 8. I've simplified by applying some exponents. That was a little tricky. Each of the exponents is even, so my negative actually just turned into a positive both times. So here's where we are. Positive 4,096 minus 65 times 64 plus 64 equals 0. Let's keep going. Okay, so 4,096. And then our next step is we should really multiply 65 times 64, which is going to be 4,160. So I'm going to write minus 4,160 and then plus 64 equals 0. Okay, so 4,096 minus 4,160 plus 64 equals 0. Are we done yet? Not yet. Okay, now it's just adding and subtracting left to right. So 4,096 minus 4,160, that's negative 64. And now it's downhill from here. So negative 64 plus 64 equals 0. And yeah, that's true. Negative 64 plus 64 is equal to 0. So I can write 0 equals 0 and done. Okay, and theoretically we would do that for all 4 solutions. If we did it again for positive 8, it would essentially be showing almost the same numbers. Once you get past the exponent step, it's pretty much the same. If you checked negative 1 and positive 1, the numbers would be much smaller, but it would still end up with the same result of a true equation with 0 equals 0. Okay, but again, for the sake of time, I'm not going to check all 4, but I know that you could if you needed to. All right, let's go back. That was example 3. Let's go back and take a look at example 4. Okay, example 4. A parentheses 34 plus 8a close parentheses equals 9. Okay, so here's the thing with this problem. It kind of already looks like it's factored. So you might think, oh, can I just set each factor equal to 0? Wait a second. But there's a 9. So no, you can't set each factor equal to 0. And also don't set each factor equal to 9 either, in case that was coming up in your mind. There's no 9 product property, okay? So this equation needs to be really rearranged quite a bit. Even though it looks like it's already factored, we need to distribute first, okay? We need those parentheses not to be there. So let's distribute the a. So we'll end up with 34a plus 8a squared, and then we're still equal to 9. Okay, now let's subtract 9 on both sides. Minus 9, minus 9. And now let's rearrange. So we're working on step 1. We're working on getting our equation in standard form. So as I'm rewriting it, I need to make sure it's going from highest exponent to lowest. So I will write 8a squared plus 34a minus 9 equals 0. Okay, so we have a trinomial. Our leading coefficient is 8. I'm looking at the 3 terms, 8a squared plus 34a minus 9. There's no greatest common factor here. So I need to just deal with the 8 being there. So what I'm going to now decide is, should I use trial and error or should I use the AC method? Well, either one would be fine. I will go ahead and use the AC method, partly just because that's what my notes answer key already has for you, so you might be following along there. Either method would be fine. Okay, so we'll just make a choice and go with it. Let's use the AC method. So A times C. So A is 8, B is 34, and then C is this -9. So if I do A times C, that's 8 times -9, which is -72. So for this method to work, I need to come up with factors of -72 that have a sum of that middle term, which is +34. Okay, so we could go through a long list of all of our factors of 72, and we would need the ones that add up to +34. Now remember, our product here is negative, so as I'm making a list, I would want my numbers to have opposite signs. If they're going to have a positive sum, I'm going to make the bigger number positive. So maybe I'd start with -1 and 72, -2 and 36, -3, let's see, and 24, -4 and 18, 5 doesn't go in, -6 and 12, 7 doesn't go in, and then -8 and 9. Okay, so that's a nice long list. These are factors of -72. We need the ones that have a sum of 34. So if I add them together, -1 plus 72 is 71, -2 plus 36, oh, there it is, 34, right here. So I don't even need to check the others. I mean, I guess I'll fill it in. Here you go. 14, let's see. So -3 and 24 is 21, -4 and 18 is 14. Then we have 6 and 1. All right. So again, just to summarize, we did A times C. 8 times -9 is -72. I needed factors of -72 that have a sum of 34. And so the factors that work are -2 and 36. Okay. Now I'm now going to use those two numbers to split up my middle term of 34a. I could do this in any order. Because I've done this problem ahead of time, I'm just going to stick to what I had done already, which is I chose to actually put the 36 first. So I'm going to write 36a and then -2a. I could easily have written it the other way. It really doesn't matter. Your work in the meantime will look different, but the final answer should be the same. Okay, so bringing all the terms down, I now have 8a squared plus 36a minus 2a minus 9 equals 0. I just want to take a moment right now to let you know I need to see some kind of work before you split apart that middle term. I believe I've mentioned this in other places lately. If all you have is just the 34 being split apart into 36a minus 2a, but you don't show any evidence of why that works, there's something missing, okay? It doesn't need to be a full complete chart like I wrote over here, but something that shows me that you did A times C and got -72, something that shows me that you understand where those numbers came from. Okay, so let's move on. Remember, we're factoring right now. So we're doing the AC method, which is also called the grouping method. I now have 4 terms. I can split them up into groups, and we'll factor by grouping. So I have 8a squared plus 36a minus 2a minus 9. So for the first group, 8a squared plus 36a, the GCF there would be 4a. So we'll take out 4a. And then in parentheses, what's left over is 2a plus 9. Moving on to the second group, minus 2a minus 9. All those things have in common is that minus sign. So we'll just factor out a -1 or a -1. So I'll write -1, parentheses. If I divide each of those terms by -1, we should end up with positive 2a and then positive or plus 9. Okay, by now you might have forgotten that we're solving an equation. We're so deep into just factoring right now, but don't forget, this is still equal to 0. We're still in the middle of factoring. So we're finally finishing up factoring so we can move on to that next step. So to finish up the factoring, 2a plus 9 is our common factor. So I'm writing that in parentheses, 2a plus 9. And then my next parentheses is 4a minus 1. So 2a plus 9, 4a minus 1 equals 0. Okay, so we made it through the factoring step. That one took quite a bit of work there. Now what we're going to do is set each factor equal to 0. So that's where we get to our two different equations. Okay, so just to rewrite a little bit here, the factors that we had 2a plus 9, and then 4a minus 1 equals 0. Each of those will get set equal to 0. So 2a plus 9 equals 0. And then 4a minus 1 equals 0. Solve each of those equations to get an answer for a. Now, a little tip, anytime you have a number in front of the variable like this, like 2a or 4a, you're going to be dividing at the end, and unless there's a GCF that you missed, it's not going to be a nice whole number, it's going to be a fraction. So we will be getting fraction answers here, just letting you know. So for 2a plus 9 equals 0, subtract 9 on both sides. So I have 2a equals negative 9, and then just divide by 2. So my first solution is a equals negative 9 over 2. My second solution, coming over to my second equation, 4a minus 1 equals 0, add 1 to both sides. So 4a equals 1, then divide by 4 on both sides. So a equals 1/4. Okay, and finally, let's check, and I think we can handle it this time. Let's check both. So we'll start with the negative 9 over 2. Okay, and now's a good time to remember what was our original problem. So here it was. So a parentheses 34 plus 8a close parentheses equals 9. So that's what we're checking, okay? So make sure you're plugging into the original problem. So I'll replace a with negative 9 over 2. All right, so negative 9 over 2 parentheses 34 plus 8 times negative 9 over 2, close parentheses, and then equals 9. Okay, so it doesn't look very nice right now, but we're going to work on simplifying. Let's do this multiplication right here. So 8 times negative 9 over 2, the 8 and the 2 can reduce to 4. 4 times negative 9 is negative 36. So in my parentheses, I really have 34 plus negative 36. Okay, so let's see. Here's where we are. Negative 9 over 2, parentheses, 34 plus negative 36, close parentheses, equals 9. 34 plus negative 36 is negative 2. So negative 9 over 2 times negative 2. The negative times negative is going to cancel. The 2's will cancel, and we'll be just left with 9. So 9 equals 9. You might have put that 2 over 1 if you wanted to. Okay, and then we'll also check the 1/4 in a similar way. So we're checking a equals 1/4 as one of our answers. Again, our original problem, a parentheses 34 plus 8a equals 9. Replacing the a with 1/4 in both of those places. And we're pretty confident if we made it this far and we factored correctly, this should work out nicely. So I know it looks a little messy, but we'll try not to be intimidated by that. If it starts getting worse and not simplifying, then that means we can stop and go back and maybe find a mistake. Okay, so in the parentheses, 34 plus 8 times 1/4. Let's do the 8 times 1/4. Reduce that, dividing by 4, you get 2. So 34 plus 2 is in the parentheses. And then 1/4 is on the outside. 34 plus 2 is 36. So I have 1/4 times 36, which is 9. So if I write that out, 1/4 times 36 over 1. 36 divided by 4 is 9. So we get 9 over 1 equals 9, which is definitely true. 9 equals 9. And there you go. Okay, I'm fully aware there's a check answer button on your homework, so I would be surprised if everybody was checking every answer for every problem, but you could. And you should check it at least as many times as you can. And at least now you know you have the ability to do that. Okay, good. So I think what I will do is I will end here, and I'm going to ask you to take a little break and come right back. There's a couple examples I'd like to look at in our homework number 30, and I'll just make that a part 2 video. So we made it through our 4 examples in lesson 30, but as you can imagine, 4 problems isn't going to cover every possible thing you might ever see in this section. So we'll end the video, take a break, and then come back for part 2, where we'll see some MyLabs Plus examples and see some other variation that we might have missed. Okay, thank you. I will see you soon.